In this video, we're going to take a look at a particular kind of exponent problem. Let me read it out for you. If 1 over 2 to the power 10 times 5 to the power 15 is expressed as a terminating decimal, how many non-zero digits will the decimal have? Now, there are a couple of key terms that we have to take a look at. One of them is terminating decimal, and the other is non-zero digits. Now I'm going to solve the problem a couple of different ways. The first method is a rather longer method, but the second method will be a little shorter than that. But before we go ahead and jump into the problem, let's take a look at the term terminating decimal. What is a terminating decimal? Now the number 1 over 5 can be written as 0.2, and this is a terminating decimal. However, the number 1 over 3 can only be written as 0.333 and so on, where the 3 keeps recurring, and this is not a terminating decimal. Now what do we mean by the term non-zero digits of the decimal? Now suppose I have a decimal number such as 0.00121. It has 3 non-zero digits, and that's what I'm referring to. Suppose I were to have a number such as 0.01. This has 1 non-zero digit. Alright, now that we've seen something about these two terms, let's go ahead and take a look at a key observation that we have to make. Dividing a decimal by powers of 10 leaves the non-zero numbers unchanged. Now what do I mean by this? Let's say I have the number 8 over 10. This can be written as 0.8. Now if I were to write 8 over 100, I would write it as 0.08. Similarly, 8 over 1000 is equal to 0.008. Now notice in all three numbers that the number 8 remains unchanged throughout, even though we are dividing by greater and greater powers of 10. This is a key observation that's going to help us solve this problem. Now we're ready to take a look at the problem. Now, before I continue solving this problem, let me write two exponent rules here, and that is a to the power x times b to the power x is equal to ab the whole power x. That's rule number 1. Rule number 2 says that a to the power x divided by b to the power x is equal to a by b the whole power x. Now keep these two rules in mind as we go along. Now let me rewrite the problem down here below. 1 over 2 to the 10 and 5 to the 15 is what we have. Now I'm going to keep the 1 over 2 to the 10 as it is, and I'm going to split the 5 to the 15 into a 5 to the 5 times a 5 to the 10. Now I'm going to bring the 5 to the 5 out in front, so I have 1 over 5 to the 5 times a 1 over 2 to the 10 times a 5 to the 10. Now a 1 over 5 to the 5, I can bring the exponent outside, so that will be equal to 1 over 5 the whole to the power 5. And I've basically used this exponent rule number 2. And now this into 1 over 2 to the 10 times 5 to the 10. Now 1 over 5 can be rewritten as 2 over 10, and I keep the exponent of 5 over there, times 1 over 2 to the 10 times 5 to the 10 is a 10 to the 10. And now I can use exponent rule number 2 again and split this up as 2 to the power 5 divided by 10 to the power 5 times 1 over 10 to the power 10. Now this is equal to 2 to the power 5 is equal to 32 divided by 10 to the power 5 times 10 to the power 10 is equal to 10 to the power 15. So now we have a 32 divided by 10 to the power 15, and this is equivalent to 0.000 and so on, a whole number of zeros followed by 32. Now we can cancel out these zeros over here because they're not important, since we're after the non-zero digits, and the number of non-zero digits is what we're looking for, and that would be 2. So the answer would be 2, since there are 2 non-zero digits. Now let's take a look at doing the same problem in an easier way. The key to solving this problem quickly is to observe that the exponent of the 2, which is 10, is 5 less than the exponent of 5, which is 15. Now we know that 2 power 1 times a 5 power 1 would give you a 10 power 1. Similarly, a 2 power 15 times a 5 power 15 would give you a 10 power 15. So what we want is to get a 2 power 15 in the denominator so that it multiplies the 5 power 15 as well. So the way to do this is to multiply and divide the given expression by 2 power 5. So let me just clear this out for you and continue with the problem. Now all I'm going to do is I'm going to multiply the 2 to the 5 and divide by 2 to the 5, and I have a 2 to the 10 remaining and a 5 to the 15 remaining. Now this is equal to 2 to the power 5 is equal to 32 divided by 2 to the power 5 times 2 to the power 10 is equal to 2 to the power 15 times 5 to the 15. Now just remind you, exponent rule number 1 states that a to the power x times b to the power x is equal to ab the whole power x. Now this is equal to 32 divided by 2 to the power 15 times 5 to the power 15 equals 10 to the power 15. So again we've got 0.000 followed by a whole number of zeros ending with 32. So this is what we're after, the number of non-zero digits, and that is equal to 2. And that is your answer. Now let's take a look at the answer, and the answer is 2 as I mentioned. Alright, this brings me to the end of this problem, and I hope that was informative and enjoyable. If you'd like to solve more such problems, do visit us at www.gre4u.com. At gre4u.com we offer personal as well as group tutoring for the GRE. Thank you and have a great day.